let's do a quick example to illustrate the lower bound, the fact that the entropy is a lower bound on the expected code word length. So let's consider our famous example A, trusty example A. So we had our four source symbols, A, B, C, and D, and then we had the corresponding code words 0, 1, 0, 1, 1, 0, 1, 1, 1. That was our code words. And then, of course, the length of each of those we know, just 1, 2, 3, 3. And we had the probabilities of each of these symbols was, we had said 1/2, 1/4, 1/8, 1/8. Very good. Now let's compute the entropy for this. Before, when we were looking at the Crafton-Macmillan theorem, I think it was, we showed that the expected code word length was 1.75. That was just by multiplying this column times this column and adding them up, of course. And now let's compute the entropy and compare it to L. So it should be less or equal. So let's check that. The entropy of this source, and it's base 2 entropy, since we're dealing with binary here. What is that? Well, that's just the sum of the pi's. So it would be, well, I guess I could put like maybe p of x here to be consistent with this notation. Log 1 over p of x, and that's log base 2. So what is this? So this is just 1/2 log base 2 of 1 over 1/2 is 2. 1/4 plus, not plus, times log 4 plus 1/8 log 8 plus 1/8 log 8, so that'll just be 2 times that. And this is, so log base 2 of 2 is 1, so we get 1/2. Log base 2 of 4 is 2, so we get 2 over 4 is 1/2, plus log base 2 of 8 is 3, so we get 6/8. And we get, so that is equal to 1 plus 3/4 is 1.75. So the entropy in this case is actually equal to the expected code word length. So not only is it a lower bound, in fact, that the expected code word length achieves the lower bound in this case. So this is a very, very good code. It's ideal in some sense. And in fact, we could have just seen that immediately by just looking at the lengths and the probabilities, right? Because we knew from before that the ideal lengths, the L stars, if we could achieve them, we can't always get them because they're not necessarily integers, but if we could get them, that's the ideal, and those are log 1 over pi. So we know that the ideal lengths are log 1 over p of x, or in other words, p of x is, in this case, 2, or 1 over 2 to the length. And it's clear that in fact that is true here, because, right, what is it? This is 1 over 2 to the 1, 1 over 2 to the 2, 1 over 2 to the 3, 1 over 2 to the 3. So in fact, this is true, and therefore these lengths are in fact not only are they optimal among all possible lengths for which there's a code, but they're in fact ideal because they achieve the entropy.